last time we talked about the first half of how the authorities decided where to look on the southern seabed. They had to look. They had to decide how wide along the seventh arc to look. And today we're going to talk about how far from the seventh arc they wanted to look. They had to decide how far could the plane have gone from the place where it gave them their last transmission, the last known transmission that they made before the plane went completely dark for the rest of time. And so it's a pretty easy walk, actually, I think. And once we have done that, once we've established exactly how the authorities knew where they were going to find this plane, then we can back up. And for the next episode, we can start to look at this whole case from a different lens. So we were talking about how the authorities used a new kind of version of the scientific method to try to understand the totality of the possible scenarios that could have given rise to the signals that they received. And they said, okay, we're going to use some statistical techniques to generate a probability heat map of where the plane might have been on the seventh arc when it made that last transmission. Okay. So it was somewhere on the seventh arc, and if we accept a certain level of confidence that we want to say, okay, there's a 99% chance that it was somewhere along this particular stretch of the seventh arc. Now, how far do we need to look beyond? Because it's unlikely that it plummeted straight down and went right into the ocean there. But listen, that's probably the most likely scenario. Planes, if we look at, for example, Air France 447 and other similar accidents, planes tend to hit the ground pretty close to their last transmission. No matter what the cause of the accident is, things tend to unfold very rapidly in airplane accidents. And so when you get to the point where you're sending your last transmission, things are usually in such a bad state that you don't really get too much further than that. I think the first thing to understand is that the most likely location for this plane probably is right underneath the seventh arc. It probably didn't go very far at all. So when you send down those robot subs and when you're scanning the seabed with your sonar, your side scan sonar, that's where you're going to start. And as you get progressively further out, your probability is going to go lower and lower and lower. So what we need to ask ourselves is, okay, what was happening at the time of the seventh arc? And then from that, let's try to figure out, okay, if that's what was happening, what did the plane likely do after that point? Now, because it gave a signal, the plane is still in the air. That's the first thing we know. The plane is not yet broken up into a million pieces. So it's in the air. What is its state in the air? Now, one thing we need to talk about, the plane was on the ground in Kuala Lumpur before it took off. The plane, was just resting there. It was turned off. It was waiting to go on this flight. And so then, the ground crew came and turned on and the flight crew came and they turned on the plane. They got ready to fly. The engine spooled up. The electronics turned on, and the plane contacted Inmarsat through the satellite. And this is the first time that the SATCOM was turned on. Every single flight starts, logs onto the SATCOM, and then it's on the SATCOM the whole time until it lands. This flight is different. It didn't log on one time, as is normal. It logged on 3 times. So let's talk about why.
So that was at 1642, right? When it took off at that point.
It took off at 1642 universal time. Which is a little after midnight local time. But we're going to stick to universal time.
So a flight that would take 5.5 hours would have enough fuel to keep it flying until 0012.
Right. So a little bit after midnight universal time is more or less, it depends, the fuel burn depends on how fast it's going, the altitude it's flying at, headwinds, tailwinds, that sort of thing. So it's only a rough estimate. But about 0012.
How much extra fuel do they put in a plane? I mean, you always assume that there's some extra, but enough to keep it going for, a little bit after the predicted flight path?
You carry excess fuel. You don't want to run out of fuel just as you're touching your wheels down on the runway. You need to have a safety margin, and you need to take into account that your airport that you're going to might be socked in. You might not be able to land. Weather conditions might not allow, so you have to go somewhere else. So they generally carry let's say 45 minutes. I don't have the exact figure in front of me, but it's something of that order. So this plane had plenty of fuel to get to Beijing, had a healthy safety margin. So it had enough fuel to stay in the air well past its scheduled arrival time. Okay, so the plane took off. As we know, it didn't proceed as normal. It turned back. It did a U-turn at 1721. And around that exact same time, it went electronically dark. I think we can assume that the SATCOM was turned off sometime around that time as well. And then at 1825, we get this all crucial event, which is the SATCOM got turned back on. Now, this is now the second time that the plane has reached out to Inmarsat and said, hi, I want to communicate on your network. Can I join? And of course, the network said, sure. Now, the plane is flying. It's transmitting these signals, as we've discussed. 2 incoming telephone calls came. They were not answered. But the receipt of that call, of those calls, caused the timer to reset. So the plane that started counting down an hour until the system wanted to recheck on it. Okay, and so the next thing that happens, and what's very relevant to our discussion today, is at 0:11, which is 1 minute before the authorities expect its fuel to run out later when they're doing the math later. So at 0:11, it makes its last kind of normal scheduled handshake exchange with the Inmarsat. So at 0:11, it makes its normal transmission. And then at 0:19, it says, once again, hi there, I want to join the network. Now, why would it say, I want to join your network? It was already on the network. Because on the plane, something must have happened. The box must have gotten turned off again. So this is now the second time during this flight that the box was turned off and then turned back on again. And so, so there are this weird thing has happened twice. This thing that normally doesn't happen at all has now happened twice. The second time is what I have tried to thump the tub by saying it's really hard to explain why this happened. We don't know why it happened. But the third time, there actually is a pretty normal explanation for why it might have happened. Not normal in the sense that it happens all the time, because what happened was probably really strange. As we talked about at the start of this episode, there's 2 lenses you can look at this mystery through. And the first one is that it's kind of all the data that was transmitted through the SATCOM was reflecting a normal state of reality. These systems were operating as designed. And so in that case, if all these systems are operating as designed, there is a readily available explanation for why the satellite communication system got turned back on, which is this.
Okay.
The plane, as we know, was close to running out of fuel around this time. Let's say it did run out of fuel. First one engine runs out of fuel, and then very soon the other engine is going to run out of fuel because they're kind of coming from different tanks. Now you have neither engine running, and so you're no longer generating thrust that's pushing you through the air and letting you maintain your speed and altitude. But there's also another effect, which is each of these engines is driving a generator, which is providing power to the 777's electrical systems. Now remember, the 777 is Boeing's first all-electric airplane. You can't control anything if you don't have electricity. And because the Boeing engineers are very aware of that, they built multiple redundant systems to make sure that this plane had electricity. Even in the worst case scenarios like this. The engines aren't churning anymore. Where's your electricity going to come from? And we were talking about this earlier. You know what happens next.
Yeah, I mean, it's probably like a car. I mean, when you're the battery... Well, I guess in a car you'd have a little bit of extra juice, but I mean, if your engine isn't running, then your electrical stuff stops working.
Yeah, but an airplane is a little bit different from a car, and so what happens is when your generators stop in this 777, what happens is there's this emergency device pops out. It's called the RAT, the Ram Air Turbine, and it looks kind of like an outboard motor. But it works in the reverse of a motor. It's actually a windmill. So it uses the plane's motion through the air to drive a little windmill, which runs a generator, and the generator is your immediate backup supply. And what happens is it doesn't have enough power to run everything. It's like a tiny little pony motor. But it drives enough essential systems that the pilots can control the plane. And It powers the start of another backup emergency system called the APU, or the Auxiliary Power
Okay.
Unit. And this is a turbine that sits in the tail of the aircraft. It's a little bit like an engine, but it's a generator. Really, it doesn't
Yeah.
generate thrust.
I was equating it to sort of like in a hybrid car, an electric car with a regenerative braking. So like that, just the act of braking is what generates power.
Yeah, it's very the RAT, the ram air turbine, that's a bit like regenerative braking. Both systems use the momentum of the vehicle to create electricity. And then in the case of the ram air turbine, some of that electricity is diverted to starting up the turbine. And then once that turbine is running, you have pretty much normal electrical power. So you're kind of back to normal, and all the systems that had gotten shut down to shed load can be repowered, one of them being the SATCOM. But it takes a little while for all of these things to happen. It's like a sequence of events. The RAT has to deploy, then the APU needs to spool up, and then the electronic box has to turn back on. So it takes about 3 or 4 minutes, something on that order. And so working backwards, it seems like a very good explanation for why this plane had to log back onto Inmarsat for the third time was that they lost engine power due to fuel exhaustion, and then the SATCOM had to reboot, and probably that meant that the aircraft probably ran out of fuel. Probably about, let's see, it was 011 to 019. It was probably like 016 or something, or 15 minutes past the hour, something in that area. Why have I just gone through this whole rigmarole? Because so what was happening to this plane at 019 as it's logging back on? Well, for one thing, it has been out of engine power for the last 5 minutes, more or less. That means it's been losing speed and or altitude. So the plane is now essentially a glider. There's no more energy being put into its forward motion. And so as a glider, it's constantly losing energy. That energy can express either as altitude or as speed. And it can exchange those things at different rates. If you pull the nose up, you might even gain a little bit of altitude, but you're going to lose a lot of speed. If you put the nose down, you're going to lose altitude but gain speed. So we don't really know, just from these facts alone, whether the plane was climbing or descending or speeding up or slowing down. They later did calculations and figured that it's possible that even at the final 7th arc at 019, when the plane had already been without engine power for 5 minutes, it still could have glided. If the pilot was like a glider pilot and like knew the best speed to glide at, could have gone 100 miles.
Wow.
Maybe even a little more than 100 miles, which is really, really far. And so if that's what happened, then the search authorities are in a bad state. They have a truly vast area of ocean that they need to look at.
Yeah.
However, is there any reason to think that that's what happened? What other clues were there that might have shed some light on this? Now, when the thing first happened and the authorities had gotten to this part of the logical process and they were trying to figure out where to look for it, they thought that the most likely scenario, because it seems so crazy that you would like fly into the southern Indian Ocean to commit suicide and just sit there for 6 long hours waiting for this thing to run out of fuel, when you could just point it in the ocean and be done with it. They thought it was most likely that nobody was at the controls. It was some kind of a ghost flight scenario. So they did some simulations with Boeing, and they saw what would happen if you just took your hands off the plane, it has no power, like it has no more. Eventually, so the reason that the APU is able to generate electricity, even though the planes run out of fuel, is that there's still some residual fuel in the feed line going into the APU. So that's not going to last for very long. And so within a couple of minutes, that fuel is going to run out too. The APU is going to stop. You're going to lose all your electricity. You have a little bit of battery power too. But before too long, you're going to lose everything. This plane is just going to be like a completely uncontrolled.
Yeah. So actually, I have a question about that too. And I don't know, maybe
Sure.
you don't know the answer to this, but let's just assume the plane was on autopilot. Does the autopilot know how to maximize how far you get to go when you run out of fuel?
That's a really good question. There's different autopilot settings. You can set it to fly a certain speed. You can fly it to hold a certain altitude. You can program it to descend to an airport. As far as I know, so in gliding, it's called best glide speed. If you're trying to get as far as you can, you want to trim your aircraft for that particular speed. I don't think that that's something that despite Captain Sullenberger's famous need to glide the thing into the Hudson, it's not a normal thing that an airline captain wouldn't need to know how to do. And so, no, I think you would have to sort of hand fly it down if you did want to stay alive as long as possible.
Okay. Sorry for that aside. I just kind of wondered,
no,
is
that's
the
a really good
autopilot so smart that it knows how to try to prevent you from crashing, or does it just kind of go? But in this case, it kind of doesn't matter, I suppose.
Right. So once the whole thing ran out of fuel, the rat would deploy. The rat presumably is still deployed, and it's still generating that minimal set of electricity that allows you to control the flight surfaces and so forth. But anyway, so back to our story. The authorities are thinking, okay, most likely this is a ghost flight scenario. Most likely nobody's at the controls. What happens if you just stop trying to fly the plane? What happens is that the plane, it starts to tilt, and when it starts to tilt, it goes into a spiral, and the nose goes down, and it goes into a spiral dive. And you're not really going in a straight line anymore. You're kind of like circling a spot on the ocean, and eventually you hit the surface. And assuming that they were able to calculate that it would have stayed within a certain 30 miles of the seventh arc. Again, it's a probabilistic thing. It's sort of susceptible to the butterfly effect. Like if there's a gust of wind, it might tilt the wing a little more or a little less. What they would do is simulation after simulation and try to see okay, if we run it 50 times, how often does it go more than 30 miles? And so they were able to convince themselves that if this is a ghost flight scenario, the plane probably didn't get very far. I would say that this happened. We know that this happens in real life. There was a case over this summer in 2023 where a Citation business jet got into a kind of a ghost flight scenario. We don't really know why. The pilot might have had a heart attack, or they might have had a depressurization. But the plane flew in a straight line on autopilot until it ran out of fuel, and it did a spiral dive.
So for some sort of reason of physics, when a plane runs out of fuel, it doesn't just fall into the ocean and at a horizontal at a perfect attitude. Is that the
right? Once it's out of control, it does not stay going straight. You actually have to hold a plane straight. It won't stay straight if you're not holding it straight. So, but then as time went by, they found another clue. Actually, they found a couple of different clues. So we've also talked about how they used this part of the metadata called the burst frequency offset, or BFO. And they did some very fancy, complicated math. It took us a whole episode to explain as to how it proved that the plane went into the southern Indian Ocean. And that was based on all of the previous 6 pings. The 7th ping turned out to have really weird BFO values. And at first, they were just couldn't make heads or tails of how they got these really weird BFO values. But finally, they made sense of it. And this is what they recognized. The BFO is generated in such a way that it compensates for the airplane's motion in the horizontal plane, meaning you're flying around the world sort of more or less at a level altitude, and it's compensating for your motion east, west, north, and south. It doesn't compensate for vertical velocity. And normally you don't have that much vertical velocity, so it's not a big deal. But in this case, they realized, wait a minute. If these strange BFO values are a result of the plane's vertical motion, that means that it was in a dive that became an even steeper dive.
Okay.
So, in fact, it becomes so steep so quickly that it wasn't a ghost flight. In fact, this must have been somebody pushing forward on the controls to generate these kind of BFO values. So now they're like, okay, now there's even a greater chance that this is within 30 miles of the 7th arc. So now they're thinking, okay, and it might be right there at the 7th arc. We don't, that's probably the most likely place. And so now using these pieces of evidence and assuming that, as I said, everything we've talked about in the last 20 minutes is premised on the assumption that this data was generated as a result of the equipment on the plane operating as it was intended and without anybody tampering with it or fooling with it. And so, that, by the way, is the assumption that the entire search, that the entire, that the official explanation for what happened to this plane is all premised on this idea that this data was produced innocently. It was produced by the machines themselves without any kind of human intervention. And so now, so as the ships sailed out from port in the fall of 2014, actually the spring, because they have opposite seasons from us. But in October of 2014, the ships are sailing out into the ocean, and this is where they're going to look. We know where on the seventh arc this plane probably was, almost certainly was, when it sent its last transmission. And we know that it's almost certainly within a certain distance of the seventh arc. So this is why the authorities, again, and this is something we've hit again and again, this is the very first start of the first episode, was talking about how confident the authorities were. We know one of these mornings we're going to wake up and we're going to find that these ships that are scanning the seabed will have found the plane. And in another episode to come in the future, we're going to talk about how that search unfolded. But we have some other things to talk about before we get there. But at this point in our story, we now understand why the authorities thought the plane went into the southern Indian Ocean and why they thought they had a really good chance of finding it, because they knew how to define a search box that gave them what they took to be a 97% probability of locating this plane.
So 23,000 square miles is where they decided to look. And
right,
it's hard for me to imagine what 23,000 square miles equates to, but I mean, that's a humongous amount of water to look for.
It's 23,000 square miles is a lot of water to look at. It's not well. I mean, spoiler alert. They wound up looking in an area much bigger than that. They wound up looking in an area many times larger than that wound up equating to the size of Great Britain. So, but that itself, I mean, listen, this is an area that's like over 1,000 miles from the nearest land. It's 3 miles deep. It's in one of the most notoriously stormy stretches of ocean in the world. And they were using technology that was still pretty new, and nothing like this had ever been tried before. Something similar had been carried out with Air France 447 back in 2009 to 2011, but that was a much easier task compared to this. So this is much worse. So we'll talk about what a daunting task it was, but it seemed like, okay, we're going to have to ask the taxpayers to give us some money to do this. And we're going to hire these contractors to do it for us. But it's money well spent, because we're quite confident the mathematics has told us in no uncertain terms where this plane is. And we're very confident that we know where it is.
It's pretty amazing.
The next episode we're going to tackle is a really big one. We've laid out why there was a vulnerability. And so in the next episode, we are going to explore the ramifications for that possibility. If this exploit was exploited, if this vulnerability was taken advantage of, what happened to the plane? It turns out to be very different from what we've just been talking about today and the previous episode.
Yeah, do that liking and subscribing and commenting and stuff, because it keeps us going, right, Jeff?
Yeah, ask us your questions. Tell us your ideas. It's amazing to me, as we're doing this, we're really learning the process as we go, but I think we now are getting a much more concrete sense of how many episodes we're going to do to take us to a place where I think the viewers really will have what feels like a comprehensive sense of what might have happened to this plane.